Hello everyone. Today we are going to see on Navis bias. It is one of a classifier which have been used in Python to predict between two classes. So this is classifier. So we are having classifier and regression. So let me just tell this difference in the later sessions. But note this: Navis bias is a classifier. So before jumping to the classes, you need to know about probability and conditional probability. I have been just said in an last video. You need to just brush up with the probability. So this is a day 18 session. Let me just run quickly on the day 17 session. We have been just seen what is matplotlib library, why it has been used, and we have been just seen how to plot respective output figures, how to label x-axis, how to provide a title, how to provide a y label, and we have been plotted with the different structures here. So this one and we have been just seen scikit learn package. For that we have been used seaborn data set. We have been just extracted a iris. In that we have been just seen sepal width, petal length, sepal length. Based on this, the species will be provided, and that we have been just seen here. And that species has been just we have been seen how to use the what is this dropping of NaN and all. We have been jumped to a linear regression. So we have been stopped at the theory part, and we have been just seen what is a coding part here. The theory part will be just discussed in the next video, that is on 19th video. Today we are discussing about Navis bias and one practical application of Navis bias, so like test classification. So we are going to see that this thing. So we are going to dive into the day 18 session. So today we are going to discuss about Navis bias. The basics you need to know about is on probability, so the degree of randomness, and what is conditional probability. Based on this, the Navis bias classifier is going to just work with. So we are going to see on one of our application here. So first we are going to see the introduction of a Navis bias and what is the algorithm for it. So second one, algorithm. So after having algorithms, we are just going for having basic coding, a sample coding. So how this Navis bias is going to just work with for single class. So that is binary class between two classes. Later we are going to just skip for multi classes, and finally we are going to have one practical sessions like how to perform a text classification. So this is like Navis bias working, and text classification is going to happen based on the Navis bias. So next I am going for an introduction to the Navis bias. So I will be just calling NB short form for this Navis bias throughout this session. So this NB is a basic, simple and faster algorithm used for classification. So classification means it is going to predict either 1 or 0 if it is binary classification. If it is of having multiple classification, it is going to provide you the multiple values like this, or you can just go for numerical values like species, what we have been just seen, like setosis or any sorts of flower name or something like this. And to differentiate it, we have been just provided the numbers like this. So this is multi-class and this binary class. So binary class means you will be having only two decisions, either true or false. So multi-class means, so the decision will be more. So the decision factors will be just high as compared to the binary classification. So the decision will be more than one in a multi-class. So that is called a multi-class classification. Okay, multi-class binary class. This is simple and fast, used for classification purpose. So this is called a basic version. So this is a very simple and it gives quicker results. So the second point is it is being used for high dimensional data. So the dimensionality will be more. So for that data set, this Nevis bias is going to work perfectly. And it is going to give the quicker results. So you may feel that you may difficult for what is this binary and multi. Binary means only two decisions, healthy or unhealthy person, diabetic or non-diabetic, bio or diabetic. Multi classification is whether he is diabetic patient, cancerous patient or brain tumor patient, like this. The decision will be more than more than two. Here the decision will be either one of the respective thinking, either true or false. Here they will be having numerous. So that is called binary decision, and multiple decisions means more than two. So next we are going to see the classification of a working. So that how this bias is going to, Naves bias NB is going to just work with. So this is based on the Bayesian classification. So Bayesian is a person who had been just provided a probability, conditional probability. Based on the conditional probability, he has been given a Bayesian theorem. So it gives a relationship between probability and statistical qualities. So statistical means some values. So here they are going to provide a relation between probability. So this is probability and statistical quality. So statistical means you will be knowing stats values. So that is like statistical values we are going to just do with. It is going to provide you a relation between probability and statistics. So next comes, so then here how he is going to do is, so as I told you earlier, supervised classification means supervised learning. It will be having labels and features. So labels means 0 and 1, features means numbers. So if we are taking example of iris, so sepal length, sepal width, petal length, petal width. So this is like one species. If the species is different, you will be having a different lengths like this. So this is called as an supervised learning. So here the bias have been provided probability of a label. So he has been just provided a relationship of probability of occurrence of a label in the feature set. So label is this one. So he is going to provide or find what is the probability of this label by observing the feature set. So this is called as an conditional probability. So conditional probability means like this, A conditional probability with B. So this is like likelihood of or occurrence of an event A in an B. So the occurrence of event of A in an B is called as an conditional probability A and B. How it is going to do? So it is having some of our equations here. So probability of A, B, which being provided with B intersection with A divided with probability of B. So this is like the respective equation. Let me just provide you the another sheet here so that it will be easier for an understanding sake. So next I will be getting the same thing here. Make it red. So probability, I will just take A. So the equation here was probability is probability of A intersection B, P of probability of B. So consider this as A probability or occurrence of a probability. This one is a B occurrence of a probability. So this part is A intersection with B. So this part. So probability of A intersection of B. So where both the occurrence is going to happen. So divided by probability of occurrence of B. So this is called conditional probability of A and B. So as per this, so they have been provided probability of labels with respect to features. So as per this definition, occurrence of a label in the features is going to give you the, what is this? So divided by occurrence of features or probability of features. So this is a Navier Bayes equation. So probability of label. So in the space of A we are having label, in the space of B we are having feature, divided by probability of B, that is features. So what it is going to say, that probability of occurring of a label inside the feature divided by probability of a features. So that is a respective equations for Navier Bayes. So this is a Navier Bayes equation. So this is going to work for binary classification, that is it is going to have only two labels, label 1, label 2, that is binary. So this is called binary classification. So next I will be just providing if we are having multiple classification. See, like the equation will definitely change whenever the labels are going to be just changed with. So if we are having labels L1 and L2, so that have been given by a equation. So probability of occurrence of a features in L1. Next, probability of occurrence of only L1. Then probability of occurrence of a feature with L2 and probability of occurrence with the label L2. So what is this feature is present occurring of a feature value in label 1 into probability of label 1. So feature occurrence of a feature in label 2 and probability of label 2. So this is the one which is going to give you for L1 and L2. So this is a feature set, use it for L1 and L2 if you are having more than one labels or multiple labels. So occurrence of a features with L1, occurrence of a features with L2 multiplied with L1 and L2. So this is like, so you are going to have a Navier Bayes equation for binary classification. So that is only one feature, and this is for multiple labels. So next one is you need to design a model which makes probability of features so probability of features with label with Li. So I can be 1, 2, 3 till the classifications or classes. What you are going to do with classes means different labels or different names. So you need to understand what is this classes. So classes means, so if you are going to decide whether the person is cancerous or not cancerous, you are having two classes. So healthier and disease one. So if you are having multiple classes like patient is heart one, brain, or what is this diabetic. So here you will be having 6 classes, healthier one, or 4 classes, healthier one, and cancerous, brain tumor, heart patient. So like this, 1, 2, 3. So you need to design a model such that it is going to make a probability for a features with respect to the labels. For each labels I am speaking, L1, L2, L3. So model should be general. So wherever we are designing, so it should be with general fashion. So it should be applicable to all the values. If you are making a classification between 2 classes, it should be applicable for any of a binary classification. So it should be general. So it should just specify the randomness process, hypothetical randomness process that generates the data. So based on the data, you are going to just generate a model, hypothetical model. So how you are going to design this model is based on the probability of occurrence of a features in label. So this is as simple as. So then specifying for each label is a main piece of training. So let me just erase this. So specifying for each label is a main task in training. So as I told you earlier, we are having training and testing. So in training, for each labels, we need to have a training part. So for each labels, we need to perform a train. So once the system is trained, so this trained model will generate a prediction. So prediction, we will be saying that y dash for a newer data x. So again you are going to compute the losses y minus y dash. Based on this, it is going to fed it back. And this is like training, testing is going to happen. So general version is tougher for training, but by assumptions we can make it simple. So I have been told about we need to have a general model. So whenever we are making a common model for all the binary classification, it becomes tough. So we need some of our assumptions. So assumptions means probability of occurrence of a features with a label. By using this, the classification becomes easier. So first I am just going to create a very simple data. For that data, we are applying a Gaussian Navier bias by using the same formula what we have been just seen here, probability of occurrence, and we are going to see how the prediction is going to just happen. First, we are going to prepare a data set. After preparing, we are going to see what are all the features we are going to just extract with. Once the features are selected, we are going to predict the newer values. Let me just tell you the flow here, how the process is going to happen in any of a machine learning. First process is to collect the data. So you are going to collect the data. So collection of a data. So this is the first process. So you need to have a good data. So good data actually means that if you are making a difference between cat and a dog. So if this is a cat picture and this is a dog picture, you need to have a clear picture. You need to take in a different angles of animals like cat and dog. You need to have at least 500 of cat images and 500 of dog images, and it should be labeled with 1s and 0. So this is called as an good data. So the next one is choose the features. So features means numbers. See, like you can just give the whole image. If it is 28 cross 28, so you can just make a multiplication here. 28 cross 28 means you will be getting around 700 something. 28 cross 28, you can just push all the 784 pixel values by converting into an single dimensional array, like 1 to 784. So this is one type of coding, but it is not a wiser one. But you need to have a wise detection. Instead of sending or detecting all the things, you can focus on some part of a specific areas. So we are going to call it as an principal component analysis or reduction of our features from 784 to some 15 features. So the time will also reduce, you will also get effective results. So after doing this, you need to choose a model. See, like if it is a binary decision, you need to go for a classifiers. If it is like detecting a continuous values means prediction of a house rent, 2000, 2010, 5000, like this will be the prediction of continuous values. So continuous values, you can just, there means you are going to select the model based on the respective application. So the next application is, or the next step is, you are going to train a model. So you are going to see what is the losses, what is how to overcome those losses and all. So once you have been trained, you are going to train the classifiers. So training is done means you are going to perform training of a classifiers. So what classifiers you are using, so that is the main thing. And just go for last step is evaluation of a classification, that is through mean square error. So mean square error means you are going to take some 50 random images. For that 50 random images, you are going to calculate a mean square for all the 50 images. Like if it is saying the true, then it is a mean square error will be 0. If it is saying partially 0 or something like this, you are going to find mean square error. So if it is false, it is completely a fail 100%. Here it has been completely just passed. So like this, you are going to find a error, losses of errors. After evaluating this, for out of 50, how much correct it has been set, that is the accuracy of a respective system. So these are all the respective steps. So collecting the data, good data, choose the features, choose the model, train the model. So after training, train the classifiers, evaluate the classifiers. So this is a very basic version of steps which have been done in any of a machine learning. So this is the thing you need to just observe with before jumping to any of our machine learning applications. So these are all the steps. I was been just telling about how to create a Gaussian Navis Bayes. So I am just jumping to the Gaussian Navis Bayes. So first step is to create a data set. So this is a random data set which have been created by NumPy. So we are going to create a data set, dummy data set, which have been used for respective versions. So after creating a data set, you are going to choose the respective features. So here I am choosing mean and standard deviation as a features. So you can just have this. So as a features, mean and standard deviation has been just chosen. So next, after choosing this, okay, first we can do this two things in an pie chart, preparing a data set and collecting a respective features called mean and standard deviation. So new scratch file, I'm going to rename it. So day 18. Okay, I'm going to rename it and I'm going to write from sklearn. From sklearn, we are going to have a data sets, and we are going to import make blobs. So blobs means circles. So some specific values. So x, I am taking two variables here, x and y. X means features, y means which have been provided for labels. So I am using this make blobs, and I am having 100, 2 with the centers. We are having two different centers and a random state. So what does this random state actually means? That if I am giving it as a value as 2, for every time these points will be not same. 100 points will be not same. If you are giving it to 0, every time the points will be same, and every time the same results will be coming. So to see the respective changes, we are changing the values. So cluster standard will be equal to 1.5. So the radius. So I am plotting. Okay, for plot we need matplotlib. So import matplotlib dot pyplot as plt. So we are just having it. So scatter. So x, I am just taking only a columns. First column. So in the same manner, I am taking the second column. So center is equal to y cluster standard deviation s is equal to 50, and color mapping. So this is a color map. I am just giving red, blue, red and blue. So let us execute this. Okay, if we are not giving plot.show, so it is not going to wait for a user to click a data or or press any of the keys. It will be automatically closing. This figure will open and close. So I have been taken x in 0 axis and first axis. So these values have been divided with the colors called, what is this, red and blue, and you are going to plot it. We are being generated, what is this, a data, a random data. Now your job, so the job of a classifier or a Navis Bayes is to get a features. So the features are simply mean and standard deviation of these points. So like it is going to generate some of our Eclipse output. So like this Eclipse output to make a differentiation between two classes. So in order to do this, we need to call a Gaussian Navis Bayes that will be available in with a function or in a respective, what is this, that is been available in sklearn. So now you need to find the probability of, what is this, so probability of feature with the labels. So we are having two labels here, red and green labels. So we are going to just find a probability of occurrence of a features on the points. So we are having some of a points. So that is red and green. For these points, we are going to find a probability of features and labels. So for a given points, so for training we will be having several points. For a next prediction, we will be giving new data or a new value. For this new point, what it is going to do or how it is going to make a classification, we are going to just see it. Okay, we can just see this in a pie chart. Okay, we can close this or else it will be continuously executing. So from sklearn, I am importing Navis bias. From that, I am using Gaussian NB. Gaussian NB means Navis bias. So I am just taking a model. This is a step. Third step, taking a model. So I am taking Gaussian NB for training. So for training a model, I am using fit function. So this is being used for training in the step what I have been talking about. So what I am training x comma y, both the values. So this is like training a model. Once the model is trained, you are going to have for newer data. So I am creating a new random values here by using a numpy. Okay, numpy is not defined here. Okay, you can import the numpy as np. See, like np dot random random state. So we are going to generate some of our random states here. So if we are giving 1 and 2, it is going to generate a different values. So now I am going to take x newer value which is not available in this training. So if we use the same data, which we have been used in a training, that case is called as an overfitting. So it has been already know all the points. You are giving the same questions and you are asking the same answers. During this time, accuracy will be 100%. So this is called as an overfitting. So if you are going for a newer values, it won't give a good results. The output accuracy will be for newer data 25%. So to avoid this, you are getting a newer value which is not present in training. So 14 comma 18. So multiplied by range what you have been just generated, and you are having a random number for 2000 values. So again in the same way, y new. For y new, prediction is going to be just present. So model means Gaussian bias, Gaussian Navis bias. For that you are predicting a new data. So for predicting a new data, the command is predict. It is a function which have been written in the model. So you are accessing a model and you are predicting a newer information. So new data has been present in x new. So now you are going to predict this data and you are going to plot it. So plot dot scatter. So scatter. Then you are taking x only columns. So x first column, so second column. What you have been just plotted for scattered variable. So the same values what you have been just done here. So you can just copy paste it. Red and blue. Now you are going to have a limits. So plot dot axis. So this is a limit, and you are going to have the same scatter. So for the scatter, you are taking x new. You are interested with only columns, first one, and you are interested with the second column. So then the same, c is equal to y new. So c is a parameter and S will be equal to 20. So then C map will be again equal to red, blue, and alpha means a learning rate. So learning rate will be 0.1. So then plot dot axis, what you are just telling to limit the x and y axis. So this is like how to predict a newer values. You can run this. Is it is working? Is it is working? Okay. So this is a data. Okay, I've forgotten to write plot show. Here I can just plot with title random data. Here I can just plot with the title prediction. And finally we can just have a show here after having prediction. You can give X label and Y labels also, not an issue. So this is a random data which have been generated by us. So this is a predicted data. So this is a random data what we have been just provided. So then we have been just scattered the newer values here. So new values. So that will be just provided in an respective version. So you are going to have a predicted values here. So later, so that was the prediction what we have been just seen with. So the random values. So the newer value will be differentiated between red and blue colors. So for a data what we are having, the new points that will be coming, so that will be just plotted near red and green values. So that is what this Nevis bias is going to just do with. So this is a random data. So you can just see here the newer data has been just printed in the respective red region, and the new data has been just shown in an blue region. So it has been differentiated the newer values into two classes. So you can just observe here. So later this we are going to just predict the probability of occurrence. So what is the probability of output, correct output which have been generated? So I am just taking a new variable called y probable, and we are just typing a model dot predict probability, and what I am giving the newer data. So here you are going to see the probability of occurrence of a model. So probability actually means that, see, I have been already told that out of this what is this newer data, you will be selecting some of 5 to 10 newer values. Out of 5 to 10, what is the correct information or correct prediction which have been done by the machine? That is going to tell you the respective probability. So probability will be just seeing, so y probable. So we are taking the last values and rounding. So we are taking some 8 values, 8 output. So as been told that some 8 output have been taken, and we have been rounding the values to 2. So rounding means, so here you need to give either 0 or 1. So you will be having like 0.000001. So it will be rounded to 0. So like this, to round it to a decimal point of 2. So we are going to just see what is this print y probability. So now we are having two classes, 0 and 1, and we have been taken some 8 classes here. 8 random values, you will be knowing what is that correct decision, whether the machine also provided the same decisions or not. So that is what we are going to just see here, probability of a output. So this is a prediction. New labels have been just plotted here. New labels with different class have been plotted here. So now here you are having a probability of occurrence. So first column is going to give you the first label, that is 0, and the second column is going to provide you the second label, probability. So it is going to just say 0.000009, and the correct decisions is 1, so it is almost nearer to 0.0009. so here the probability of occurrence is going to just see, so with label 0 and label 1. So you can just change it to decimal point 1 so that you can just have another clear picture. So the points will be shifted. So this is what the first column will be telling here. So this first column will be telling that, so if you are, these two things will be providing you a probability of occurrence of a two labels. So first one is for first label, second one is for probability of a second label. How exactly your machines have been just scattered the information. So this is for, what is this? Binary classification. So next one will be like, we are going for probability for finding the multiple labels. So probability for binary classification we have been just seen here. There is a mouse. So this is the binary, and I am talking about if we are having any of our multiple classes. So if a decision is more than 2, then we are going to call it as an multiple labels. So Gaussian assumption is made simple assumptions that specify the distribution for each labels. So if this is a label, you have been distributed the newer points across that respective labels. So you have been distributed by using Gaussian values or a Gaussian theorem. See, like this is not going to work for a multiple classes. So we are having a multinomial. What is this? Okay, we have been just seen what is Gaussian Navis bias, how to generate our data, how to train. So train is like using a command called fit. So then we have been predicted by using a model.predictor. We have been just seeing the multinomial Navis bias. So this is another method for predicting the probability between each category. So category 1, category 2, category 3. So categories can be anything. It can be dog, it can be cat, it can be horse, anything. So category of names. So we are going to just provide the probability between each categories. So this idea is same, only that we are going to have a multinomial distribution of a data. So here we are having some 20 categories. So the real-time example, we are having a 20 categories. We are going to classify the text. So we are going to take a data set already built, already available in an internet, that of different categories. I will be telling which groups of categories we are having. We will be dividing into a features and labels. After providing this, we are going to train the model. In a prediction, I am giving my own sentences. Machine will say that this sentence have been belonging to which category. This is another very real-time application which have been used for text classification. We can just see this. Okay, let us see how to start with the coding. See like how to get 20 different groups of thing like groups of text classification. Okay, let me just start with a new program. So I am importing from sklearn dot datasets. So import fetch 20 groups. Import fetch 20 news groups. So data like I am fetching a 20 news groups. So here it is going to have a text referring to 20 fields of news channel. So now our aim is to design a model which can take text as an input and say the respective group to which it has been belongs to. So let me just show you what are all the target names which have been available in this data. We can print the target names, and we can just say what are all the fields, like 20 fields which have been just available. So here I am just importing a fetch 20 news group. From that, a data set have been pushed to a variable called data. Okay, we need internet connections here. Let me take a internet connection. Wait a second, let me just do this. So I would just suggest you to have internet connections for you also while executing this respective program. So thing is like you have been just taken a fetch of a 20 news group and you have been just printing the news channel. Okay, let me execute this. Okay, I'm having an internet connection. Okay, it may take some time to get a text. So in the meantime, we can just see that we will be having some uh, groups of like sports, like science, computer graphics. It can be technology, bicycle, motors, like this. So these are you will be like having a 20 different groups like this. In that, you are going to categorize some of three groups. See, like out of 20, you are interested with designing a classifier. First, you will be training a model with 20 groups. Later, you are designing a classifier to detect only a three groups. I have been just chosen like out of 20 the three groups. In that, we are going to train it. So like this, the procedure is going to happen. So let me wait for having this to just execute. Why this is taking time? So this is based on the system speed and all. So whenever you are executing, this may not take this much of time. So it differs from system to system, or based on from how much time the system is going to be in an on condition. So now I am running so many apps here, video recording, audio recording, screen recording and all with the PPTs. So it may just take some time. Let me rerun this. Okay. Okay. That was a system glitch. So first, computer graphics, atheism, OS level, that is any of a Windows level. If you are having any hardware issues, so then system hardware, Windows related, autos like automobiles or motorcycles, that is bike, sports, in that sports, baseball, sports hockey, cryptography, electronics, science method, science space, social religious, in that Christian, politics, politicals, Buddhist, misc, so religious factor. So these are all the 20 different groups which have been available in this respective data set. In this 20 groups, I am categorizing only some of a, so first I will be taking all the 20 and I am just training a model. So now I am interested with only few of the things like record, motor, cycles. So first one. So next one like science with a space, or it can be electronics. It can be with science with a space. Then with computer graphics. So these names should be the same as the names which have been provided in the dataset. So this is a head. So this should be same. You cannot change it. If you are changing one spelling mistake is going to happen, means also if any of a spelling is going to be just changed, it won't get invoked. So what I am telling is out of 20, I am using only 4 categories to train a model. So now I am taking a train method, so variable. In this train, so training option, what I am doing is like, so from a data set, what I am doing, I am fetching the subset. I am telling that the option is I am performing a training operation. So categories I am using as this variable. So this variable I am using for categories. So as it is a variable, there is no need to use quotes. So for out of 80 news packages, I have been selected only 4 now. It has been reduced. The training has been reduced to only 4. So next comes testing. So testing also same, but I am just saying the subset as test, and categories is remain same. So from a data set, we are interested with only 4 things. We are accessing it and we are performing training and testing. So print train dot data of 5. So some random data I am choosing, that 5 means 0, 1, 2, 3, 4, 5 from this 5th, 6th element. So later you are going to just see how it is going to change the data set here. Now, so you can see that the data set have been just changed to these many values. See here. Now, so this was one of a name. So he has been performing in Silicon Graphics. So if this was a sentence, sorry, I missed you random, I am from the last month. So these are the sentences, email IDs. So this sentences will be categorized into a respective fields which we have been just provided. So these are the sentences. So we certainly want to know about VR, virtual reality. That will be under, what is this, com graphics, what machine supports VR. So if this was the kinds of a text, it will be telling that it is in the field of com.graphics. So it depends. So these are the texts which are being just provided online with a databases. So it has been collected from years. So like this, it has been just provided. So this is a data set of 5. So like this, you can just see here. So you can just see the print, train, print test as well, and you can just see print data as well. So you can just see all those things. So like this, you can see the data as well. So data will be like from which website it has been taken, and this will be a raw information that will be just converted into train and test. So like this, you can just see all the information. So this is what you are going to classify your data. So next, what's the thing is, okay, let me take a pen here. So we are going to perform classification of a text. Okay. So classification of a text, let me tell the ML steps. So that was the general structure what we have been discussed. Collecting a data, collecting a features, good features, selecting a model, train a classifier, evaluate. That is a general step. So this is like what all the procedures we are going to do with. First, we will be converting our data to vectors. So single vectors. So if it is having 28 cross 28, it will be converted into 1 cross 784 if it is an image like this. So the next one is, we have been converting into a vectors. We are using PF IDF vectorization method. So this was one of a vectorization method which have been used to convert your text to a vector format. So in the third one, we are using multinomial Nevis bias to classify the respective text. So these are all the steps which are being used in our programming. First, we are taking data. We are using vectorization method. After vectorization, we are simply using multinomial Nevis bias. So here we have been taken a data now. So now we are interested with extracting a features. So from sklearn dot feature extraction dot text, and you are importing tfid vectorizer. So you are importing it. So in the same manner, you are importing, so from sklearn Nevis biases, you are going to import multinomial Nevis bias. So then again from sklearn, you are using pipeline and you are importing make pipeline. So pipeline means one after the other. So after doing this, I am having a model here. So model is equal to make pipeline of by using TFID vectorization and multinomial Nevis bias. So pipeline have been created. So first you need to do vectorization. So this model is like, it has been designed like do vectorization and call multinomial. So after this, I am training a model. So training means I need to use a fit command. Training.fit, train.data, comma, train.target. So target values are here. So only this one. So target and I am having a labels is equal to model dot predict what I am predicting test dot data. So we are having one model, it has been trained. So now we are going for testing it. So labels, for labels variable we are pushing the predicted value. What we are pushing? The test data, and we are predicting it, and it has been seated in a variable called labels. So again here we will be getting which label it is. So we will be generating a confusion matrix. sklearn dot matrix import confusion matrix. So what does this confusion matrix actually says? That it is going to provide you a picture that what is a degree of rightness of a machine. So it is having true true, true false, false true, false false ratio, and it is having type 1 and type 2 errors over there. In order to understand that, you need another hour here. I will be just pushing a one confusion matrix video. You can just learn what is confusion matrix from that video. So for the for the understanding sake, what you can understand is it is a graph which is going to tell you what is a correct decision, how much of correct decision, how much of false decision. Okay, I am just providing the labels. So I am generating a confusion matrix here. So confusion matrix. So test dot targets comma labels. So here there is a function called SNS heat map. So SNS means import, what is this, seaborne value. SNS heat, you are going to have a transpose of a matrix. So square will be true by using square, anot will be true. So this is like animation. fmat is equal to t, color bar will be false, as we are not going to concentrate on color bar. So x tick labels. So x tick labels will be equal to train dot target underscore names, and y tick labels will be equal to train dot target names. So this is like what is a confusion matrix, how to generate it. So x label should be true label. So plot is not defined. So import matplotlib dot pyplot as plt. So plot dot x label, plot dot y label is predicted label. So this is predicted versus true. So in the x-axis you will be having true labels. For this label, the machine have been also set the same answer or not. You are just seeing. If it has been said same answer, then it is fine. If it has been said wrong answer, then it is going to decrease the accuracy. So you can run this. So now we have been taken a data set. We have been using a vectorization. So model is vectorize the data and call the multinomial NB. For that we have been using train data, sending train data and testing data to train it. So train data, train target means data and labels. So after training is completed, you will be saying what is the predicted model. Okay, it is having some error here. So it is heat map. Oh, I have been written only heat. So now after having a training, it will be taking newer data and it is going to predict the labels. So now it is going to, we need to forgotten to write plot.show. Okay, it will be generating a confusion matrix for us for training and testing values. So group of data set is printed. Okay, this is a confusion matrix. So you can just see the 4 labels here: computer graphics, motorcycle, electronics, science as space. For this is we are having some of a data set. Out of that data set, so computer graphics have been correctly concentrated as a computer graphics itself for 335. It has been recognized for motorcycle with 6 cases, and here you are having some confusion between graphics and an electronics. So it has been wrongly detected as 26 here. Space also. So instead of this one, it has been detected as space as 22 values. Coming to motorcycle, it has been correctly detected 395 and 6 as a confused value, and it has been wrongly detected to space also. So this is having higher accuracy for Navis Bayes. In the same manner, you can see for science for electronics, it is having 332 and misclassified for other classes. In the same manner for space, it is of having a higher accuracy comparatively to the electronics. So 385, 711 have been misclassified. So this is called as an confusion matrix. So predicted label, true labels. So this is a right answer, and this is a what the machine have been provided. You can just imagine that the question paper will be provided by the examination committee or a competitive committee. So these are all the answers which in y-axis what you are writing. If it is correct, then you are right. If it is wrong, then if you are predicting it wrong, or if you are writing a wrong answer, you will be writing for other classes like this. So this is a scenario of confusion matrix. So let me just define a function called predict the category. In that, what we are sending, one is string and the other one is trained data. So trained model we are sending. So next we are just going to give a model for it. Okay, so this is a respective models. So after defining it, we are just saying, taking some variable called predict. So model dot predict, what you are taking, the string what you have been provided by the user. So yes, the same variable you are predicting, and it has been just sitting in a model in a variable called predict, and we are ending it. What we are ending, we are returning with train dot target names. In the target names, what we are pushing, prediction of 0. So we have been predicted this value. So in that, the first element will be the name, that will be returning back to the respective main program. So now I am just calling this prediction and I am sending a data, sending the payload to moon. So this is of science friction, science dot space. Let me see whether it will give a correct decision or not. So these are all the user defined sentences. So speedest motorcycle in the world. I am just providing sentences. I am not telling which speed motorcycle is in this thing. Ferrari, not Ferrari, Suzuki. So next one is predict determining the screen resolution. So this is computer graphics. So now we have been trained a model and we have been seeing the confusion matrix also. It has been considerably detected successful data, and it has been made some of a confusions because of uh, confusing words between or correlation between the two fields, or correlation means similarity between the two fields, like computer graphics and electronics may collide like this at some instance. So here we are going to predict the results. We can just see the confusion matrix again. Okay, target names. Okay, there is something error here. Where it is? Sending the payload to moon. Okay, self.key. Okay, let me see step by step, one after the other. Okay, you can see that sending the payload to ISS, it is of relating to the space. Okay, the name was not written like target underscore name, it was being written, that's why it was generating some errors. So let me just see the other thing, like predict category determining the screen resolution. So you can just see how to predict the newer text. So let us see that whether it is going to say the correct answer or not. Now I need a computer graphics here. So the some computer graphics need to be just displayed. Let me see whether it is going to give or not. So like this. Print. Let me just check for other category what we have been just given here, electronics, whether it will be providing the same values or not. Diode keys forward bias. Let me check if the class is there, it will be providing the target names for this. Okay, the confusion matrix. So it is saying that it is an electronics field version. So next one, let me go for print predict category. What I am predicting, motor, which is the best motorcycle to buy within 1 lakh. Let me see whether it is going to provide a correct answer or not. Okay, confusion matrix. Okay, it is saying that it is resembling for a motorcycle. So these are all the categories we have been just given and we have been tested, and it is providing a good results comparatively. You can give the user defined values here for your respective experiments. You can just train your other groups. So you have been seen many groups here. So like you can take other categories. So other categories you can just see, and you can just, instead of going for motorcycles, electronic space and graphics, you can go for other categories as well. So this is version of how to just have a text classification, and this is also another real-time application where you can just rename this file to do text classification of what is this news group. So this is one of a respective code you can just do with. What I have been all done is, first I have been taken a data set. So these are all the imported values for what I have been imported. So for what I am using, I have been just imported here. So I am taking a target names. So target names means labels to which it has been just belonging, and out of 20 I am taking only 4. So and I am training it, testing it, making a pipeline, and made a one model. Using this model I am training the classifier for data set, train data, train target, and I am predicting it, and I am moving that labels to a confusion matrix. So what I am being predicted, out of some 20% have been just taken for testing purpose. Later I have been just made a what is this confusion matrix, and I have been shown plot.show to hold the execution till the user will close the what is that figure window, and I am just defining one of a function which take the string from the user and a model and a trained data, and it is going to provide you the which category it has been just belonging to. So this is a string we are sending, and it is telling the what is this, like what is the respective value or to which class it has been belonging to. The first person to land on the moon. Let me see whether it is going to work with or not. Power gone. Okay, it is space. So like so that was an example of a real-time exposure, how to classify the data between 4 categories. You can just extend the categories to 5, 6, 10, anything, and you can train it, and again you can test it. So let me just give a difference between classification and regression problems, so you can understand what is classification first. So it is going to provide you a discrete values saying 1 or 0, 1 for us, 0 for no. So in the regression value, it is going to give you a continuous values. Continuous values means it is a whole numbers like 10,000, 10,500, 5,000, like this. And output version in a classification is, it is going to provide you a name of a person in health domains, like whether the person is healthier or not healthier, cancerous or not, diabetic or not, hot patient or not. So this is classification part. Regression is an house rent prediction, gold rate prediction, continuous value you can observe over there, the price value 100, 200, 50,000. During that cases, you need to go for regression based model designing. If you are designing is like yes or no condition or deciding between saying the names of a person, you can go for 20,000, 10,000 names and all, but it is just a yes or no like thing. So here continuous prediction is going to happen. So this is a main difference between a classification and a regression. So that's it for the video, guys. I hope you have been had a wonderful session. Let us meet you in the next video. Thank you. This you can just go for any of a user defined values. So that's it for this video.